It's made possible by having tools that do chemical analysis, I think. Sorry, long answer. Yeah.
Is there, how long do you think it will be before this enters the operating theater?
I believe it'll be on the order of approximately, I'm guessing, on the order of like 3 to 5 years.
So already in Stanford?
Already at Stanford, they're interested, and it's going to take a while for this to I'll tell you, the medical community is very conservative.
How costly is the mass spectrometer?
This is the other big piece of news. The particular mass spectrometer I'm showing you was quite costly, but you don't need it. If you go back to that citrate glucose ratio, I could do that with a really cheap portable mass spectrometer. See? And therefore, let me answer the mass spectrometer, which the Air Force, I was able to convince them, was running something like $500,000 or so. Really large, right? And I'm very lucky to get this. Anyways, very lucky to have it. But you can imagine, and people are working on this, that in the future we're going to have mass spectrometers that cost in the order of about $1,000 to make and be sold for $10,000. And once you have one of them, you can use it for all these patients. Then it really takes care of it. Yes.
Yeah, most of the microbes can also be identified when looking at genetics. Have you tried looking at, as you know, the metagenomics is identification of microbes, and microbiome is a big thing.
Yes.
Have you tried using your system?
I have just very few people. I have very little support for this work still. I'm sorry. And instantly, no way do I own this. Please, anyone here, take this, do something with it.
Currently, the standard metagenomics techniques, as you know, that takes a very long time. You go through the sequencing, etc. So
I'm claiming this should really shortcut this process and speed it up. And we're on the verge of learning so much more. And there's so many, in our gut, there's so many interesting things that are going on for the number of microbes we have. And coming to India, I'm getting a whole new set.
Cardiac markers, like proposing and prostate cancer, things like that.
I want to. I'm actually talking with someone about this. I think our fingerprints are going to help us with cardiac markers. And I started, the person at UCSF, at the University of California's San Francisco Medical School, I'm sure you've worked with that. It's open to all types of things. What about diagnosing cystic fibrosis? What about, see, all these, again, there's so much here to try. And it doesn't have to be sweat.
What is the
I'm going to try another.
saliva? What is the rate that you
Saliva.
in
Spit.
sensing we have something like nanogram per ml. What you need typically, what is the minimum and what is the range?
Oh, I bet it's on the order of, believe it or not, femtograms.
10%.
Yeah, I believe so. I think I'm right in saying that. Because you can count individual audience. You don't need much. But what you really need is you perhaps have heard me show you. So is you need pattern recognition. And we have to put statistics back into play here to get it to be really good. So there's an interesting combination that's going on.
Question here?
Oh, yes.
You have used your technique of mass on solid samples, frozen section. You have used for liquid samples. Do you plan to use it for gaseous samples? Because it is known that people who are suffering from cancer, they emit some volatile organic compounds.
Exactly. Now, I was going to tell you about that. So here's a project. I've already suggested this to my group, and I'm waiting to see what will happen. What I say to them is get something in which you take breath and you breathe on something which can absorb it, and then you can use the deci back on it, and you can accumulate it this way, as an example. So I've been proposing that. No work is going on this way. It's going to happen.
There is an Israeli group which has predicted cancer.
Okay, from breath, but not by
Not
this technique. But so I know it's possible. And again, that's why it should, and breath, analyzing breath is to me non-invasive. I like it. Okay, I like non-invasive things, I don't like needles.
Suppose if we take the SPECT profile annually, can we find markers that we want?
I'm hoping so. This is the type of thing I'm thinking of. I'm also, all types of things I'm thinking of that way, that we could start to monitor
So that
better.
it becomes a diagnostic tool.
Yes, we just have to play more. So I think there's going to be a big change. And hopefully, this really worries me, if I may explain to you. Now, let me go into a different direction, a different axis. I'm worried about cost. Too much in the United States anyways involve medical breakthroughs that cost too much, so they can't really be applied except for the wealthy, or something like this. The things I'm telling you about look to me like they will in time be made very cheap. Okay, that's important, because then they can be applied to everybody. Okay, you can imagine screening this way, and that matters to me. Okay.
Thank you very much.
Oh, thank you.
Thank you, Professor Zare, for enlightening us to this lecture and also patiently answering all the questions. To express our gratitude, I would request Nakul Sharma, the President of the Chemistry Society, to present Sir with him. I also request Ms. Ashwini Rajpal to present Sir with the college ceremony. Now I request Dr. Ekta Kunja, the Staff Advisor of the Chemistry Society, to present Professor Ramaswamy with a small token of gratitude. Thank you very much, ma'am. Before we conclude the session, I would like to quote a few lines from Dr. Charusita's autobiographical article in the book, Leelavati's Daughters. She said, "Being an Indian and a woman are as intrinsic parts of my identity as is my interest in doing science, and I have tried to integrate and do justice to these different aspects of my identity." I hope you are able to emulate Professor Charusita, an exceptional student, teacher, and researcher who has made our college and the nation proud. Professor Ramaswamy, we promise you that we'll always remember her in our hearts and will make her and your dreams come true. Now I request Dr. M.S. Frank, the head of the chemistry department of Stevens College, to felicitate Professor Zare and propose the vote of thanks.
Indeed, it is my honor to propose a vote of thanks on this solemn occasion. Charusita was one of the most illustrious and brilliant students this college has had. And it's very sad to have a promising life cut short by its dreaded disease, cancer. Now, fight against cancer, we have many obstacles, and today Professor Richard has enlightened us through his brilliant talk how we can use mass technology to analyze specimens for cancer cells and maybe in a matter of minutes. I take this opportunity first of all to express my gratitude to Professor Richard on my own behalf and on behalf of all of you for his scintillating and gripping talk on the use of mass spectrometry as a diagnostic tool in the treatment of cancer. Not only cancer, many other diseases that are likely to be covered with this technique. A big thank you, Professor Richard, for readily agreeing to deliver the first of the Charusita Memorial Lectures. We are delighted to have you with us, and we look forward to many more opportunities wherever you are in India. If you have to go via Delhi. Yeah. And then, secondly, I take this opportunity to thank Professor Ramaswamy for instituting this fund for perpetuating the memory of his beloved wife, Charusita, in the form of his memorial lectures annually around the last week of March. He not only instituted the fund, but also taken keen interest in every detail of this event right from the beginning. We are grateful to you, Professor Ramaswamy, not only for instituting the fund, but also in bringing Professor Richard, a close friend of yours, to deliver the first Charusita Memorial Lecture. Thirdly, I am grateful to Dr. Maini, Dr. Vij, and Dr. Sachdeva